Okay, so part 2 of this lesson is going to be about the measures of spread, but let's just review real quick the measures of center. We have mean, median, and mode. We're typically going to use the mean unless there's an outlier, because if we have an outlier, the mean will be skewed. We're going to use the median if there is an outlier because it is least affected. It is called a resistant measure. And then remember, mode is the least reliable measure. So let's talk about the measures of variation. Sometimes I will use the measure of spread, that term. Sometimes you may use the measures of variability or dispersion. They all mean the same thing. It's just talking about how spread out the data is about your mean. So we have 3 measures of variation, or 3 measures of spread: range, interquartile range, and mean absolute deviation. And we're going to look at these definitions a little bit more in detail. Now, you may have heard of all 3. I'm sure you've at least heard of range and interquartile range. So with range, what I would like for you to write down is that this is a value, a measure that's unreliable. So it really doesn't give us a lot of information, especially if you have an outlier. It really is not a good indicator of how spread out most of the data is. So therefore, we will use the interquartile range. The interquartile range is the more stable stat that is used, and it looks at the middle part of the data, the 50% of your data set. It is the range from your Q1, quartile 1, and quartile 3, and we'll get to that in a few minutes. So it disregards any possible outliers that are to the left or to the right. So it looks just at the middle part of the data and gives a better idea about how spread out the data really is. Our mean absolute deviation is the 3rd measure of our variation, and the MAD lets us know, again, how spread apart the data is. And the larger the MAD, then the more spread out the data is. And it really helps you to see this when you're comparing 2 data sets like we are with Jude's science grades and Jude's math grades. So we'll be able to see which grade set is more predictable. If his MAD is small in science, then his science grades are more predictable. But if the MAD is smaller with his math grades, then he's more consistent in math. And that can go with the IQR as well. So the smaller the variation, the more predictable that the data is. Okay, a 5-stat summary. You may have not heard of that term, but I'm sure you've created a box and whisker in the past. And those 5 numbers that create a box and whisker, that is really the 5-stat summary. So we have the first number will be our maximum, then we'll get our Q1. Okay, Q1 is the first part of the box, and then Q2, our median, is the middle part of the box, or the line that's in the box, and then Q3 is the end of your box, and then the minimum is the dot to the right. Oh, I have these out of order, but that's okay. Your maximum is going to be your largest number, and your minimum is the least number. Once we get these, we can find our interquartile range by subtracting Q1 and Q3 from each other and our range from the max from the min. So let's just look a little bit more in detail of how this works. But then I'm going to show you how we can get all of these numbers from our calculator. So quartiles are values that divide a data set into 4 equal parts. So, and then each part is 25% of the data. So you start out and you divide your data. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 numbers. Okay, so the median, okay, is going to be between our 40 and 44. So we have 6 numbers on the left, 6 numbers on the right. So what we have to do to get the median, or Q2, is average these 2 numbers. If we had an odd set, we would have a direct median right within our data set. So we add these and divide by 2, and we get 42. So we have divided the data into 2 halves. Now, here we have our half on the left and our half on the right. To divide these up again to get 4 parts, we take the lower set and we find the median of the lower set. So we have 6 numbers. So again, we're going to have to use these two, 26 and 32, and average these to get the median of the lower set. The median of the lower set is the first quartile, Q1. So it's 29. Then we're going to find the middle number of the upper half to get Q3. Again, we have an even amount of numbers, so we're going to have average these two, 53 and 55. That gives us 54. So our quartile values are 29, 42, and 54. And remember, these are values, not a range of values. There's just actual numbers. So you can see that we have 4 parts. So 25% of the data is below 29. Then we have 25% here from 29 to 42, and so forth. So if I said what percent of the data is below 42, that would be 50%. You can see that from Q1 to Q3 is 50% of the data. That would be your box in your box and whisker. Okay, that would be you would find your interquartile range by subtracting 54 minus 29. That would be your IQR. So again, I'm not going to show this video, but you can open it up and watch it if you need a recap of how to calculate. So it's a lot like finding the mean. You're going to do the exact same steps, and you can clear your data by clicking second and then 0 for reset, and then 2 is yes, you want to clear the memory. Then you're going to input, let's do the science grades first. You're going to click data, and you're going to be in list 1, and you're going to enter all his science grades. After you enter a number like 85, you click enter. So you keep going until you get all 11 grades in. Now you're going to go to second stat, which is the data button. We want to go to the stat feature. So second stat brings up this menu. And again, we're doing univariate data, means one variable. So click enter. Then again, we're in list 1, and our frequency is by ones. For this course, we will always use a frequency of 1, and then click enter to calculate. Now this time you are going to scroll down. When you first see it, it shows the average and a few other stats that we don't need right now. You're just going to scroll down using your arrow button, and you can see that on number 8 is your Q1. So this would be, so when you're writing down your 5-stat summary, you can just write them down in a row, and you can use, I like to use the French curly brackets, and then just use a comma after each one. So if I was to write this down, I would write 82, 88, that's my median. Oh, I'm so sorry, we didn't do the minimum. Let's do the minimum first. So our minimum with the science grades was 52. So that would have been under 7. I have it right here. So on number 7 is the minimum. So I would do 52, 82, 88, 94, and 98. And so that's your 5-stat summary. Okay, so we're going to use these numbers to make a box and whisker. So first of all, our minimum number was 52. So that is 152 about right here. So I'm just going to plot the 5-stat summary first. And then our first quartile was 82. So this is 80, this is 82 is here. And then our Q2, our median was 88. Then our third quartile is 94, and our maximum number was a 98. So you can see that most of the data is like, in the B's to the A's, not this 50 down here. So you can see this probably will be an outlier. So let's make our box. So the box right here, this will be our IQR value, and then put a line down for our median, and then we have our whiskers. This is probably not going to be too straight. That's okay. Okay, so we can calculate the IQR is the length of your box. So we had 94 was here, and then this number was 82. And so when we subtract those, we get an IQR of 12. Now we can go ahead and get the range. The range is from 52 and 98. So when we subtract those, we get 46. So you can see that his range of grades is really not a difference of 46 numbers. If he wouldn't have had this outlier, his range would be so much smaller, more predictable. Okay, now we're going to do the same thing for his math grades. So again, clear your calculator and input his math grades. And you're going to go through the same steps. Again, if you need to pause the video, pause. And you're just going to clear it. That's second 02. And then go to your data button and input his grades. Once you get those in, go to second stat. And it is one variable. And you're wanting to do list one and a frequency of one. And then you're going to scroll down. And I'm going to write out. So we're going to write this out. So 82 was the minimum number. 89 is Q1. 93. So if I ask you this on a quiz or whatever, this is what I would, real easy, just write it out. Okay, now let's plot these points on the number line. So, or actually above the number line. So we have 82, we have 89, we have 93. About right here, we have a 95, and we have a 98. So you can see that this box is way smaller, but the whole box and what's our plot is smaller. So it doesn't look like there's really an outlier here. So again, our IQR is going to be from 89 to 95. So that is just a difference of 6. And then his range in math is just from 82 to 98, and that is a difference of 16. Okay, now let's calculate the MAD, mean absolute deviation. So what we're going to do is find the mean of each set. We've already done that. Then we're going to subtract that mean from each data value, and we'll have a distance. Some will be negative numbers because some values lie below the mean, and then some values will be positive because they lie above the mean. So then we'll take the absolute values of those distances. So when we're subtracting, we're getting a distance. It's just the distance from each data value to the mean. And then we want to get the absolute value of those distances and average them, and that's your MAD. And it just tells you the average distance that each data point is from the mean. Okay, so I have a template, and if you just want to write this on your notebook paper, that's fine. Or if you have a printer, you can print out these templates. It's nice to have. It helps you organize the data. So the first thing that we're going to do is put all of our data points, and if you want to put them in order, that's fine. I am just going to list them as they are. So we're going to put all the numbers. Make sure you write them correctly. 52 and then a 98. Okay, so that's the first step. Then the second step is we're going to put the mean. And the mean, and when we're doing the mean, we're always going to just typically round to the nearest whole number. It depends on what kind of data set we're looking at. So I want to write this all the way down. And then we are going to find the distance that each data point is from the mean. So this 78 lies below, so we know it's below the mean, so it's -7. And 96 is above the mean, so it's going to be positive, and we get 11. And then 88, that's going to give us a +3. Then we have 82, which is below, so that's a -3. We'll have a +9, a +5, a -3. We have a +8. Then we have a distance of 0. And then we have a big negative here. And then we have a +13. So then once we get those, then this represents a distance, so we want all positive numbers. And no, there's no way that we can do this in our calculator, so we do have to do this, but using a template really helps us organize. So now we're just taking the average of these distances, and that'll be what the MAD is. So the total number that we get from this, when we add this up, is we get 95, and then the number of grades is 11, and then when we divide to get the average, we get 8.6363. So it keeps repeating. I don't want us to round much on these. I mean, we are going to round, but let's say 8.6. So the MAD is 8.6. Okay, now we're not going to do the outlier on this page. We'll do that in just a minute. Okay, so that's the MAD for his science grades, 8.6. That probably is not, I don't know if that's high or low. It's really hard to tell unless you're comparing it to another set of data. So that's what we're going to do now. So let's use our template and put our data points. We have 96, a 92, a 94, a 98, a 90, 93, 88, 95, 82, 95, and 89. And then his average was a 92. 92, 92. Just all the way down, and then we're going to subtract them. So when we subtract, then we get a positive 4, 0, 2, 6, negative 2, 1, negative 4, positive 3, get negative 10, positive 3, and a negative 3. And then when we add, now we got to do the positive of those. Okay, so let's take the absolute value part. So let's go through this. So the mean, here's the mean of the data points. Okay, and now we're doing the absolute value of these. So all the positive, because it's a distance. And then when I add these up, I get a total of 38. There's 11 grades. And then the average gave me 3.45 repeating. So let's just say 3.5. So now we can actually compare. So you can see the range. Again, this is not very relevant, especially in this one, since we have a possible outlier. Our IQR for science is 12, so still more spread out than math. So he is more consistent. So we're looking at these two, either IQR or MAD, to tell us which course he's more consistent with. So our MAD is 8.6 for science and 3.5. So you can tell that with an IQR of 6 compared to 12 and a MAD of 3.5 compared to 8.6, then math he's way more consistent and the data values are clustered more together instead of being spread apart like he is in science. However, with that possible outlier, let's just say it is an outlier, and we're about to prove if that 52 was an outlier. If 52 was an outlier, we would use the IQR for science, okay? Because that 52 skewed the mean absolute deviation. So this is a lot higher than it probably should be if we did not have the 52. It would be probably a little bit more closer to the 3.5. So let's do that then. We are going to find we're going to check the lowest number, 52. So this is how you do it. You put in a possible lower fence. And then we need the Q1, so of science grades, and we're doing science now. So Q1 was 82, and then it's subtract, and then it's 1.5 times your IQR, and our IQR was 12. And in my calculator, I'm just going to make sure you use appropriate order of operations. So I have 82 minus, and then in parentheses, 1.5 times 12, and that gives me 64. So, is this true? Is 52 less than 64? Yes. Therefore, 52 is an outlier. Okay, so we have an outlier, which means that we would use the median for our center number, and we would use IQR for our spread number. These are our resistant measures. Now, let's go ahead and make sure that there's not an upper fence. So the largest grade is a 98, and this time we have greater than, and this time we use Q3, which was 94, and we say plus, and then we have that 1.5 times 12. So when I calculate this, I get 98 is greater than 112. This is false. So no, 98 is not an outlier. Okay, so here is our template sheet that has all the data for Jude science grades. Now let's calculate the possible outliers for his math grades. So the least grade up here for math is 88. No, sorry, 82. Yep, 82. So 82 is less than, and then the Q1 for math was 89, and then it's minus 1.5 times the IQR, which was 6. And then when we calculate this, we end up getting 82 is less than 80. That is false. So 82 is not an outlier. Now let's check the largest, the upper fence, a possible upper fence. So 98 is greater than Q3, which is 95, plus 1.5 times your IQR of 6. And when we get this number, it says 98 is greater than 104, and that is false. Therefore, 98. So in his math grades, there was no outlier, so we would use the mean for the center number, and we would use the MAD for the spread number because there's no outlier. Okay, so just a quick caption, a quick summary. Measures a center, mean, median, mode. Measures a spread, MAD, IQR, range. Just kind of keep in mind that mean and MAD, they both deal with mean absolute deviation here. You're going to use these two values if there is no outlier. Mean is your center number, MAD is your spread, how spread apart the data is. If there is an outlier, you're going to use the median and the IQR. Your median is your center number, your IQR is how spread apart the data is. Remember, the smaller the IQR, the smaller the MAD, the more predictable the data is, and it's clustered more together. And then just keep in mind that mode and range are your least reliable measures, and they're rarely used.